All right. Can anyone hear me? I'm not using my microphone today. I'm using my webcam. Can you hear me well, or should I use my earphone?
Yes, we can hear you, sir.
Okay, it's good, right? Okay, let's just take a few moments to scan your attendance, and then we'll begin today's class. Let me just get my usual earphone. Okay, I am back. Can you guys hear me now? Is it better? Working?
Yes, sir. Good.
Okay, all right. Thank you for the response, because otherwise I wouldn't know if my mic is okay. All right, thank you. Welcome back again to our class today. It's been a week since we last have our class, so I really hope that you guys have had a good week. And last week also, I remember that we made a promise, right? So we didn't have class on last Thursday because it was a public holiday, and I also didn't. I don't wish to spoil anyone's holiday, so I've decided to not give any assessments on that day also. But we did promise that today, last week actually, we did promise last week that I'm gonna post a video, and you guys will have to watch those video before coming to class. So I hope that everyone in the class last week, you were aware and you have also watched the video. Okay, because at the end of this class today, we'll have a little assessment based on the video and based on what we are covering in our class today. All right, so before we start our class, just a little bit of housekeeping announcements. I realized that there are new students joining this class. I think last week, sometime last week, or maybe a few days, maybe yesterday, the latest one. So if you're new to the class, welcome to the class. We have had, for your information, we have had some assessments already. If you're new to the class, we have had like 2 quizzes already. So if you're late into the class, I would like you to attempt those quizzes as well. So if you go to the quizzes assignment tab, you would see that there are quizzes that is already assigned to you. And as I have mentioned in the last class, if you are the quizzes will be open throughout the semester for submission. So I don't wish to block anybody's submission. If you want to attempt, the quiz is always open. However, if the quiz has got a timeline, and the timeline is 1 day after the quiz is assigned, right? So if you submit after 1 day, so your submission will be a late submission. Okay, unless you are able to produce a valid excuse, such as an urgent, an urgent matter or something. Unless you let me know that, I am going to take that anyone else that submits after the deadline is considered late submission. Okay, so this is so that everyone else who follows the deadline is fairly treated. Okay, so we have to have this idea. So in my class, the idea is that everyone gets equal opportunity, equal chance. So the chance is given to everyone. So it's up to you to take those chances. So if you decided to not submit, I am not going to bug you. I am not going to force you. I'm not going to say anything. In fact, it is totally up to you, because this is I believe everyone here is already an adult, and I would like to treat everyone as an adult. and I won't like pester you, or I won't say anything actually. Okay, so you know what you should do to do well in the class, and I am here in my position. I'm ready to help you as long as you are ready to help yourself. As long as you're ready to attempt, as long as you're ready to take action, I'm here to help you. Okay. All right. That's that. And okay, talking about quiz. I'm not sure if you guys are aware. Uh, these following students, you guys did not. I'm not sure if you guys didn't know that you haven't submitted, or you guys thought you've already submitted. So I'm just going to do this once. After this, I'm not going to mention this anymore. Okay. So this students, Naveen Manimaran, I think you're new to the class. You saw the quiz, but you have not submitted. Tamil Vanan and Tanbir. I'm not sure if you guys are aware that you haven't submitted, or you guys are not aware actually.
I'm sorry, sir. Yeah, I was the one who emailed you the answers, so I wasn't aware that the submission was open actually. So yeah, I'll resubmit the thing in this quiz.
Wait. You are Naveen, right? What about the other two, Tanbir? Are you aware that you have not submitted, or you are not aware? Okay, it's okay. I'm just gonna say this once, because every semester there will be students who like, oh, I didn't know, like I have to submit, and then it's like the end of the semester. So after this, I'm not gonna ever mention again who's not submitted and who is submitting late and so on and so forth. So just to let you guys know on this one, just this time, okay? All right. Okay, so that's for the quiz. And yeah, before we begin today's class also, I would like to ask again that if anyone right here in this class this semester who's facing any kind of difficulty in following my lectures in the online class, so I want to let you know that I am here to help you guys out. So if you think you guys don't have a good enough computer to follow the lecture, or your devices, your phone is not good enough, please do reach out to me. I believe I've posted one message last week in the group. So if you have reached out to me, thank you very much. I will forward your case to the to the person in charge, and hopefully we'll be able to help you out. Okay. All right. Just to make sure that, and let's continue with our class today. Okay. So welcome back to our class, and let's go to our PowerPoint slides. Yeah. Okay. Okay, so last week, just a very quick recap on what we have done. Especially if you are new, you might want to know what we have covered so far, so that you are not left behind. Did anyone say something?
Yeah, I think your slide, I can see your slide here. Just the QR code right now.
Yes. This is the QR code. Yes, correct. I was just about to click on next, and then
okay. I think
yeah.
you just start already. Okay, sorry.
Okay. All right. So thank you very much. I don't mind like these interruptions, or you have any questions. Okay. So right now, let's continue with our class today. And last week, what we have covered was this topic on number systems. All right. So if you were in the class, we did cover a good amount on what is the basics of number systems. Okay, what is number systems all about? Number systems are a language, but it's for computer. So it's just like us, human, we can communicate in so many different languages. Computers communicate using number systems, using a few number system that we're familiar with right now, decimal. Okay, we have a binary, we have octal, and we have a hexadecimal. So in reality, there's more, but we are not going to talk about every single one out of that. In fact, in this course, we're just going to focus on the binary number system from this point onwards. But last week, we also covered a little bit on the surface on how do we count, what are number systems, how do we count in each number systems, and if you have a base 2, this is how you count from 0 to 1, and then next, and so on and so forth, right? So we covered every single one of this. If you have not clear yet, I encourage you guys to watch last week's video lecture as soon as you can. Okay, on that, and this is how to write them. Yes, this is the value, and then you have something called the radix. Radix is the base number. Okay, so this is another example. Okay, right. So we talk about binary number, and in binary number, yes, this is an important term. We'll make use of this today. We have MSB and LSB, stands for most significant bit, least significant bit. Yeah, I hope you guys still recall what are those. This is just the leftmost bit, and this is just the rightmost bit. Okay, So from this point on, I'll just mention, okay, the MSB, what's the MSB and what's the LSB? Okay, it is understood that the MSB is the leftmost, the LSB is the rightmost. Okay. Okay. We also talk about counting. We did some exercise, I think, for counting, and then like after that, we did I think some examples on base conversion. So last week we've done a lot of base conversion examples, I believe, in the class. And to sum it up, we arrive at this point. Okay, remember? So this was the diagram that you can use to convert any number system to any number system. Okay, for example, you have binary, you want to convert it to hex, you can use this. First, you can do weighted sum, and weighted sum gives you decimal number, and then you can do the integer part or fractional part depending on the situation. Okay, and that gives you all these choices over here. Okay, and other than that, last week also we've covered some very neat shortcut on whether on situations where you need to convert from, let's say, binary to hex, or say binary to octal, without doing all this weighted sum and doing this integer part, fractional part in between. Okay, so this only works for binary, octal, and hex. Okay, so if you want to convert to decimal, there's no other choice. You can only do weighted sum. Okay, the shortcut, I repeat, the shortcut that we covered last week only works when you want to convert between binary, octal, and hex. Okay, if you want to convert from binary to decimal, there's no other way but weighted sum. Okay, if you want to convert from decimal to binary, like for example here, there's no other way but to use this integer or fractional part. Okay, because I've noted that in your quiz, some of you have attempted that shortcut method to convert from binary to decimal. Okay, that doesn't work. Okay, so hope you guys are aware of that. And yeah, let's take a look. Yep, so we did on, this was the last slide, I believe, in the last lecture. Okay, so we did some conversion over here, and remember we did some kind of a grouping, and then like this gives you an instantaneous way to convert from binary to, in this case, it's hex. Okay, right. So hopefully things are clear right now. Okay, as I said just now, if things are not clear, I highly encourage you guys go back today. Like, don't delay, do not wait, because online lectures, it's very different from face-to-face lecture. Face-to-face lecture, I know that you don't understand by just looking at your face. All right, I already developed this skill, but in online class, I don't see you guys, so I really don't know whether how good is your understanding. Okay, so it's like you are on yourself unless you reach out to me and say, sir, sorry, I don't understand. Can you just repeat this part or that part? Unless you do that, I really have no clue. Okay, I'm just a human being just like you. I'm trying to help you guys as much as I can. Please do reach out to me if you have any problems. Right, let's continue to our class today. In today's class, we are going to look at another very simple aspect of numbers. So remember that in your primary school, once you know what numbers are, like you already learned 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. The next thing you will learn is how to perform some kind of operations on them. So these operations are known as arithmetic operation. And this is what you are seeing on the screen right now, arithmetic operation. These are the basic ones. It's addition, subtraction, multiplication, and division. Okay, so just like in decimal number systems, you can do 10 plus 10. Okay, in binary, you can also do 10 plus 10. Okay, you can perform this in any number system. So any number system, there is a way to do arithmetic operation. All right, let's take a look at this one. Okay, so this is the one that we are most familiar with. This is the decimal addition. So decimal is the number system. Decimal means base 10, and this is in the case of addition. So I don't think I need to elaborate on this one already. All right, this is how you do the addition. You go, okay, this is what I want to highlight over here. You go column by column, right? So over here, what we do is, let's say you have 18 plus 19. The first thing you do is you take number 8, and then you take number 9, and then you add them on the first column. And then what happens? And then you get the answer, right? You get the answer 17. So you write down over here 7, and then there is a carry, and you bring that carry on to the next column. Okay, that is what we are doing in a decimal number system. Okay, I know this is boring, but bear in mind, because I'm going to carry this concept on into the decimal, binary, and addition operation after this. Okay, now in the same way, so if for subtraction, we also go column by column. Okay, let's go on to see what is on the menu today. So we have over here binary addition and subtraction. So this is how it looks like. Okay, pay very good attention to this one because this is the highlight of today's classes. Every semester, students get lost here. So look carefully. If you don't understand, just let me know. All right, so on the left over here, I have an addition table. So what this addition table does is it's got few columns over here, and you have a column A and column B. So column A and column B is known as the, I'm just going to write down here, these are the O, P, E, R, A, and D. These are known as the, if it's plural, it's operands. Okay, operands means the thing that you are adding. Okay, so over here, the operand is, everything here is all the operand. So over here, 0 is the operand, 0 is the operand. Okay, the operation is addition. The operands are the number that you add. Okay, let's go for example here. Over here, I have 1 and 1. So this 1 over here is the operand. This one is just another operand. Okay, and this over here is the operation. Okay, and this guy over here is the, this is okay, let me just okay, this guy over here, this number over here is, this is the result. Okay, so yeah, so actually they are both the result. Sorry, yeah, they are both the result. So, and you have one more thing, is called the carry. So when you add things, sometimes you have a carry on top over here. Like, okay, this guy is the carry. Okay, so hopefully those are clear, the terms. The operands, you have the operands, you have the operation, and then you have the result. And in some situation, you will have the carry. So these are the 4 columns that you are seeing on the screen over here. Okay, let's take a look at the subtraction table over here. Similarly, for subtraction, you will have operands as well. The operands are A and B. Okay, sometimes you have more. Okay, but this is the simplest of the simplest. You have just A and B, just 2 numbers for you to subtract, and then you have a result, and you would have a borrow. Okay, borrow is the borrow that you understood from decimal subtraction. It's the same thing. Now, let's take a look at how this thing works, because it's already looking very strange, I bet, because what you're seeing on the screen is something very alien. Okay, what do I mean by that? Look at this. I wrote here 1 plus 1 is 10. Okay, I bet this is not something you're familiar with, but this is true because what we are doing is binary. Bear in mind, binary addition, binary subtraction. Okay, let's take a look at how these things work. Okay, in binary, remember that in binary, the first ever number in binary is 0, remember? And then what's the next number? The next number is 1. Okay, and then what's the next number? The next number is 1, 0. What's the next number? 1, 1. Yes, what's the next number? 1, 0, 0. Okay, do respond, you know, like if you want to respond, just do respond. I really appreciate if you guys are responding like that. It gives me more motivation to teach and to help you guys out more and to make this class more interesting. Okay, so right, let's go back here. So take a look at this number, right? From 0 to 1, what we're doing here is we are adding. Okay, 0, and then you add 1 value up, it goes to 1. And then you add 1 value up, it becomes 1, 0. Okay, I purposely say 1, 0, and I don't say 10 because I know you guys will be confused the moment I say 10. Okay, 1, 0, and if I add 1 more, it becomes 1, 1. Okay, remember this is in binary. Okay, binary number system. All right, and so on and so forth. Okay. That is how binary works. Binary counting works, right? Last week we covered that. Now let's take a look at what is it that we are seeing over here. Okay, so over here, what we have is these 2 operands, 0 and 0. So what we're doing here is we do 0 plus 0. Okay, 0 plus 0. Okay, I don't think I need to say this, but you have nothing and then you add with nothing. Your answer is nothing. Okay, so you have result 0 and you don't have any carry because there's nothing for you to carry on to the next column. Okay, simple case. All right, this one done, right? Now let's take a look at another simple one. Now you have 0 and 1. So 0 and 1, it means that you're doing this one, 0 plus 1. And what do you have? You have nothing, and then you add 1 to that, and you have 1 as the answer. So over here, what you have 1 as the answer. And do you have any carry? We don't have any carry because carry is a situation where we have like an extra digit and then we carry over to the next column, right? So in this case, we do not have carry, so that's why we have 0 as carry. Okay, now let's take a look at the next one. Now in this case, we have over here 1 plus 0. I'm looking at this third row over here. Okay, so 1 plus 0. So the result will be the same as the previous one. So you have like 1, and then you add nothing to it, like you still have 1. Do you have a carry? No, you don't have a carry. So that's why the result is 1, and then the carry is 0. Okay, now let's go on to this last row over here. So this last row over here, you have 1, and then you get at 1. So how do you go about that? Okay, so if you have 0, okay, take a look here. You have 0, then you add 1 to it, you arrive at 1. If you have 1, now you add 1 to that, what do you have? You go 1 level up, and that 1 level up in binary is
1 0.
1 0, right?
1.
Because that, yeah, there's no such thing as 2 in the binary number. Okay, it's 1 0. So that is why over here what we are seeing over here, you have 1, you plus another 1 over here, the answer will be 0. Okay, 0. That's the result. Okay, over here so far. But we have also something we call a carry, because there's an extra digit over here. We carry on to the next column, and over here we have 1. Then you plus with nothing. Okay, and then it carries down over here. So that is how we get this answer, and your carry over here is 1. Okay, is that clear, everybody?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
All right, thank you. So far so good, right?
Yes, sir.
Okay, now I'm gonna throw another question. So what if you have 1 plus 1 plus 1? What do you have?
101.
Any other answer?
1
1 1.
1 0 1 1 0.
1 1 0. Okay.
1 1.
1 1.
1 1. Okay, there's so many answers, right? Okay, so right. Let me show you again. Okay, I'm gonna go back to this this again. So this is the okay. Let me color so that things are clearer. Okay. So we start here. Okay, so we have 1 in our hands. So what happens if you add 1? If you add 1, you go up 1 level. You end up with 1 0. That was what we did over here. Okay, you have 1, and then you add 1 more, then you get 1 0, right? So if you have 1, you add 1 more, you get 1 0. Now we are doing the same thing. So you have 1, you add 1, then you add another 1. What do you have? So the answer will be 1 1. Okay, so to those who are okay, is that clear, everybody? That is how it works. When you add 1, it goes 1 level up. Okay. Okay. Take some time to digest this because this might be an alien concept to you. Because we are doing, we've been doing decimal. We have been thinking in our human brain. We are so used to thinking in decimal. Okay, so we do 1 1. Of course, there's 2, right? Two fingers like that. Okay, but this is not how it works in binary number. Okay, all right. So actually, at the end of the day, all you got to remember is this table here, and you can do any kind of addition. Okay, I'll show you guys through another example later on. So, but bear in mind, this is how this 4 rows are the only thing that you need to remember. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 0. This is all you need to remember. Okay, now it's the same for the subtraction table. Now let's take a look at this subtraction table. Okay, all right. So for subtraction, it is also very straightforward. So you have A and B. So over here we have 0 minus 0. obviously you have nothing, and then you minus nothing, so you have nothing. Okay, 0 is the result and 0 is the borrow. Okay, self-explanatory. Right, same thing over here. Let's go to the second row. You have 1, and then that's all you got, and now you minus everything. So what you have in the end is also a 0. Okay, and because you minus the amount that you need to minus out, you need to subtract out, is just nice. You don't need to borrow with anyone. Okay, so that is simple. So that's why there's no borrowing involved. All right, now let's take a look at this case over here. You have 1, you minus nothing. Okay, simple. You have 1, you minus nothing. You still have your 1. Okay, and there's also no borrow involved. Okay, now the trickiest one is like this one. When you have 0, but then you need to minus 1. So how do you solve this? Okay, obviously one thing you know, right now there will be a borrow. There will be a borrow. Okay, so let's try to solve this problem in decimal. So I'm trying to illustrate this key concept to you, but let's do this in decimal first, and then we come back to this one. Okay, so now you guys tell me, like in decimal, right? Let's say I get 110, and okay, maybe 100. Okay, 100, and then I tell you that, okay, you got a minus 27. Okay, this is in decimal, right? Can you believe this? We are doing this problem in university. Okay, we are doing 100 minus 27 at the university level. Okay, but bear with me. This concept is going to apply in this binary subtraction over here. So in the case of decimal, right? Let's say you have this kind of a problem, and what you do is you immediately see that you don't have enough to subtract. Okay, so the first column here, you don't have enough to subtract 7. So what you do is, instantly you know you got to borrow. You got to borrow 10. From where you borrow? From the neighbor. Okay, what's the neighbor? Oh, the neighbor also doesn't have anything. Okay, so the neighbor has to borrow from their neighbor. Okay, so this neighbor borrows from this, and at the end of the day, this one becomes 0, and then this neighbor becomes a 9. Correct? Still remember, right? Okay, so and then you can do the subtraction, correct? So you get 10 minus 7, you got 3, and then you got 9 minus 2, you got 7. Now, have you ever thought, why is it that when we borrow, this number becomes 10? Why is it not 15? Why is it not 16, 17, 18? Why it must be 10 over here? And then the second time you borrow, it must be 9 over here. Why is it that the case? Okay, so it's because of, let me show you this table again. Okay, it's because of this, remember? So, okay, this is the column that I am looking at, decimal. Okay, so when you borrow, right, you don't have enough for 1 digit. When you borrow, what you're doing is you borrow from the big brother that has 2 digits. The first element of the 2-digit number is this guy. You borrow from this. Okay, and the second time you borrow, you take this value. Okay, now that is going to work the same way over here also. Okay, so in binary case, so when you borrow, the first element the first time that you borrow, you're going to get this value. And the second time you borrow, you're going to get this value. Okay, so that works also. Let's come back to our example here. Okay, we are going to look at okay, this one, right? So coming back over here, so we have this case over here. You have 0, and then you have 1. So what you do, you're gonna have to borrow. Okay, borrow from where? Borrow from a neighbor. So you don't see the neighbor over here, but in a computer, you always have a neighbor that you can borrow from. Okay, so the first time you borrow, what value do you get? You get 1, 0. Okay, clear? I'm gonna go back to this table again. The first time you borrow, you're gonna get this value, 1, 0. Same thing in decimal also, the first time you borrow, you're gonna get this value. In binary, the first time you borrow, you're gonna get this value. That is what you're seeing. Now, okay, let's go back. The first time you borrow, you get a 1, 0, and then you can do the subtraction. So the subtraction goes 1, 0, you minus 1. So how does that work? So coming back to over here, we see you have 1, 0. Previously we do addition, right? Every time we add 1, you go to the next level. But now we have 1, 0, and then you want minus 1. What do you have? You have 1, 0, you have minus 1, and you go down one level, and what you get is 1. Okay, so that is why your answer over here is 0 minus 1. The result is 1, and then because you borrowed, there is a borrow over here, 1. Okay, is that clear, everybody? This is how you do addition and subtraction. Any issues so far?
Sir, can I ask a question?
Yes, go ahead.
So the 1 0 that is borrowed is because based on computers, there will always be the neighbor. Is that right? Oh.
Yep. So for now, you don't have to worry about, okay, where did this number get this 1, 0, okay? Don't worry about that right now. What we are trying to show over here is just how the operation is performed, okay? From where this number is borrowed, that will be a topic for another lecture, okay? Maybe not in this course. I think it's in your future course, okay? I think in microprocessor or something in your maybe 3rd year, or maybe in some of your elective. Okay, but for now, just know that this is how the operation is performed. Okay, you have 10, you minus 1, you get a 1. Okay, if you notice over here, it's the same operation over here. Okay, it's the same operation over here. You have 1, you add 1, you get a 1, 0. If you do the reverse, you get 1, 0. You minus 1, you get a 1. Okay, it's the reverse over here. Okay, any other question before we proceed? So far, so good? Okay.
So
do
far,
let
so
me know.
good, sir.
Okay,
Yeah.
sir.
Do let me know. As usual, I will post the video as well after the class. This lecture is also being recorded, and I'll also post short videos covering the things that we are talking about. But right now, what is different compared to you watching the video, okay? What is different is that you can ask me live, okay? I'm here to tutor you live. This is the value that I am providing. So if you guys are not asking, if you guys don't make use of this, then it will be like, you just watching YouTube, like there'll be no difference. So I really hope that you guys can make use of this. If you have any question, just do let me know, okay? All right.
Sir,
Yes.
actually, sorry, one more. Based on the video that you posted, right? How they do the process is when you borrow one, that thing becomes 2. So is that just how to do it faster, or is it fine to just do that way?
Yeah, I mean that 2 is just an illustration of this one value higher. Okay, and you guys know that in binary there's no such thing as like 2, right? So it's just a concept for you to do this subtraction. Okay, so if you want to use that method, at the end of the day you will still arrive at the same answer.
Okay, thank you, sir.
Yeah, it's just an intermediate concept that you use to understand how it works. Okay, 2 is like one level. If you take a look at this value, 1, 0 here, right? So this is equivalent to 2, but this 2 is in decimal. Okay. Right. So I'm not sure which one are you comfortable with. If you want to use 2, like you want to imagine that there is a 2 over here and then there's 2, you minus 1. Okay, go ahead, but do bear in mind that in binary value there's no such thing as 2, and this 2 is you gotta bear in mind that this is a decimal equivalent. Okay. All right. Any other question? All right. Okay, so let's go ahead and do some more challenging question. Okay, so over here we have, okay, so this is a more complicated one right now. Let's take a look at how we do this. So we have like a few bits of binary number here, and we want to add them together. So using what we have learned so far, we are going to do this. And as usual, we are going to do column by column. We are going to go from the right to the left. So we're going to start over here. So we have 1 and plus 1. What do you have? 1 plus 1 is
0, 1.
0,
0, 1, 0, sorry.
okay, 1, 0. So the answer here, the result is 0, but you have now a carry.
1.
Okay, now same thing. Carry over here, you need to add again, and then over here you have a 1 as a result. Now this time there's no carry, right? Okay, now then we go on to the next columns. Yeah, we have 1, 1. Same thing. 1, 1, you get this, 1, 0, okay, with a carry, 1. And then you have like a 1 plus 1 again. 1 plus 1, okay, the same thing, you get a 0, you get 1 again. And then what you have over here, 1 plus 1 again. Okay, 1 plus 1 again. Okay, I'm going to write this. Now, in the final row, you have 1 plus 1 plus 1. Okay,
1, 1.
that is 1, and then you have a carry 1. Okay, and this carry eventually gets put over here. Okay, that is how you do the addition. So simple, right? Right. I don't think okay, this is super complicated. Let's take a look at subtraction. Okay, let's take a look at this. This is the number that I have over here. Now, let's try to do this subtraction. So, first column, 1 minus 1, okay, simple enough, 0. 0 minus 0, still 0. 1 minus 1 again, okay, no problem with that, 0. Now you get 1 minus 0, okay, still very straightforward, that's 1. Now, over here we have a problem. So you have a 0 and you have 1. So what needs to happen is that you need to borrow from your neighbor. So you got to take this, and then you got to put this here like 1, 0. You can put 2 if you want, like if that helps you understand, like please go ahead. And then over here, now you're left with nothing because you will have 1 and then that 1 got taken away. Now you have nothing. Okay, then you have over here 1, 0 minus 1, and that gives you a 1. Okay, remember the base number. Okay, can everyone wrap your head around this? So far so good.
Yes,
Yes,
yes.
sir.
Kind of. Okay.
Okay, now I want to challenge you one more level higher. Let's take a look at another example here. I'm going to change this this question slightly. Okay, so we have 1, 0, 0, 1, 1, 0, 1. Okay, so everything here is the same except for the last digit I added something. Now this one's the same. Sorry. 0, 1, 0, 1. Okay, let's see. And I want you guys to do this subtraction. Okay, if you have a pen and paper, please do work it out with me. Trust me, when you do it on pen and paper, you get it much more faster. Okay, so let's see. Okay, let's try to do it. Okay, so first column, 1 minus 1, 0. Second, 0. Third, 0. Fourth column, 1. Okay, now this is where it gets interesting. So the first time you borrow, what do you have? Cool with that, right? So the second time you borrow, what do you have?
0.
1.
1.
You get 1. Why is that? And then this guy now becomes 0. Okay, now remember the table I showed you just now. Okay, the table I showed you just now. Always come back to this table. Okay, so the first time you borrow, this is the value that you get. Okay, in the binary case, the first time you borrow, this is the value that you get. Second time you borrow, this is the value you get. That's in the same case, in binary case, the binary number, first time you borrow, this is the value that you get. And any after borrow with that, you get this value. Okay, so that is why the second time you borrow, on the third and fourth time also, you get the value of 1. Okay, so hopefully that makes sense. All right, so let's go back to our challenging little example over there. Okay, so that is why the first time you borrow, that is here, you get 1, 0. Second time you borrow, and the third time and fourth time you get this value. Okay, now with this borrowed value, then we can solve this problem, right? So you get 1, 0, you get minus 1, you get 1, and then over here you get 1, and that gets carried down. Okay, and that is your final answer, 0. Okay, remember the base number. Okay, so this is something alien, I know. Take your time to understand this, but make sure you understand this before the next class. Okay, if you have any question, please feel free to throw them out, either in the chat or right now, or just get in touch with me. Okay, so as usual, we also have binary multiplication and we also have binary division. So I'm not gonna go very into detail what's how is multiplication being done and how is binary being done. You can have a look at the table over here. This is the operand, okay, and this is the answer. So 0 multiply 0, get 0, 0 multiply 1, get 0, 1 multiply 0, get 0. The only time you get 1 is when you have both of this 1. Okay, that's just like usual multiplication. There's nothing different over there. Okay, and yes, this is how you do multiplication. And I want you guys to work this out at home as well. It's just the same as we do the normal multiplication. You go row column by column. Okay, so this is the answer that you should get. Okay, same thing with binary division as well. It's very similar to the decimal binary division. Okay, and I also want you guys to work this out with pen and paper at home. That's the best way for you to understand this. Okay, so that is binary arithmetic. So we are going to finish our topic binary arithmetic right here. And after this, I'm going to go into a short introduction to another topic, and then we'll conclude the class. Let me take a sip of water. All right. Okay, so today you've learned this binary arithmetic. There's one concept. Now, this is the second key point of today's class. So the second key point of today's class is the introduction of signs. Okay, signs. So far, we have considered that there are a few number systems: binary, you have decimal, you have octal, and so far. Okay, so far, we have only considered positive number so far. We have not talked about negative number. Okay, so in the same way, in decimal number, you have positive 10, but you also have negative 10, right? In decimal. Now, in the same way, in binary also, you can have negative numbers as well, because your computer needs to process negative number after all, right? So we need to show, so in the computer, we need a way to store this number, including the sign of the number. So this is what I am trying to say over here. This is the concept of signed versus unsigned binary number. Okay, so far, we have, until this point right now, we were only talking about unsigned binary number. So when we say unsigned, what does that mean? Unsigned means the value is always positive. I haven't talked about negative value so far, right? So it's only it's either it's positive value, or the second possibility is that it's 0. It's either positive or 0. Okay, but in reality, we also have negative numbers. Okay, and in this topic, we are going to see how we store this number with a sign. Okay, so a number with a sign is called a signed number. Okay, and in this case, because we are dealing with binary numbers, and if that binary number has a sign, positive or negative, it is known as a signed binary number. Okay, right? I think that's self-explanatory. Okay, so signed binary number is very simple. Okay, so if you have a string of number, right? So this string of number must include the sign. Okay, let's take a look at the example. Let's say this is a string of number, right? Very long number, like 10111000. Okay, very long number. Imagine this as a very long number. Now, how do you write the number as positive or negative? Okay, for human beings, if I write this, okay, you know that this is negative 100, because you're a human being, you recognize this as a negative sign. But for a computer does not recognize signs. A computer only knows numbers, and a computer only knows two numbers. In fact, it only knows 0 or 1. Nothing other than that. It only knows two values. It's either a 0 or it's either a 1. That's how computers work. They're so bad. They're so primitive, so basic, and that is why computers use binary number, right? It's either 0 or 1. So let's say you have this number, right? -100. So how are you going to tell the computer that this is actually a negative 100? It's not positive 100. So we have to have one digit of the number to represent the sign. So this is how we do it. So the MSB is always going to represent the sign. And the rest of the number, it is a magnitude. Okay, let's take a look at the example over here. Let's say you have this super long number over here, okay? And the sign of the number is represented by the MSB, okay? MSB, most significant bit. So the MSB shows you this number is a positive or negative number, okay? And the rest of the number, they are the magnitude, okay? The number in blue is a sign, and the number in red, they are the magnitude. Magnitude means is the value, okay? The value of this number. Okay, now, what does this MSB tell you? This number positive or negative number? So it's very simple. In fact, this is the rule of thumb, okay? You got to remember this. If MSB is 1, is a negative number. So if you take a look at 1 over here, if you rotate the 1, it looks like this, negative, right? So if you see this MSB is a value of 1, you know that it's a negative number. Okay, and the other way around, if the MSB is 0, then you know that the number is a positive number. Okay. Example, let's take a quick one. MSB is 1. Now this is a negative number, okay, because MSB is 1. And the value of the number is this, 101. Over here, MSB is 1. This is a negative number, and the value is this. Okay, whatever this represents, you can do the conversion yourself. Okay, you can convert this to base 10 if you want to know what's the real value here. Right. Take a look at this one. Same thing. Now you have the MSB to be 0. You know that this is a positive number, and then the value is this 4 bits. Okay. So far, we know that, okay, there's 2 types of number. Signed number, there is also unsigned number. Unsigned number is everything that we have learned from the beginning until just now. And today we know that, okay, there's something called the signed number. And if I tell you that this number is a signed number, then automatically you know that, okay, this is a signed number. I need to see what is the MSB so that I know it's a positive or negative number. Okay, but it's not that straightforward. Okay, I'm going to show you why. Because there are 3 formats of signed numbers. So 3 formats of signed numbers. Okay, so the first one is known as the sign dash magnitude format. Second one is this first complements format, and the third one is the 2's complements format. So we're going to cover these 3 things, and then we'll end our class today. Right, first thing, sign magnitude format. So sign magnitude format is the simplest of all. This is the most simple, but it's not used very often. Okay, so it's the same. The MSB shows you the sign bit, and the rest are the magnitude. Okay, so this is an example over here. So let's say I have a number. This number is a decimal number, and this number has got a positive sign. And I tell you right now, okay, express this number in 8-bit binary sign magnitude form. Okay, there's a few components over there. I want you to take note. 8-bit means there is 8 digits. Okay, it's got to be 8 digits. Okay, fine. And it's got to be a binary number. Okay, no problem. 8-bit binary, that makes sense. But now you also have this signed magnitude form. Okay, so how do you write positive 25 in an 8-bit binary signed magnitude form? This is how you write it. So I'm going to put this as a box. So each box is going to represent 1 digit. So in total, you have like 1, 2, 3, 4, 5, 6, 7, 8. 8 boxes, 8 numbers, okay? Because we are dealing with 8 bits. Now, first thing you want to do is you want to check the sign. Is this number a positive or negative number? It's positive 25, right? Positive 25, what's going to be the MSB? The MSB has got to be 0. Remember, just now the rule of thumb. MSB 0, it represents a positive number. So I'm going to put the first digit over here, 0. Now, what about the rest? So the rest over here is going to be the value. So what's the value of 25 in binary? So do the conversion. So you got a 25, and then you do the division, right? You do division, and so on and so forth. And after you're done with the division and you read it from the bottom up, this is what you will find. You will find that the value is 0011001. Okay, so that is how we write positive 25 in 8-bit binary sign magnitude form. Okay, clear, right? I think this is kind of straightforward. Okay, now let's tweak this question a little bit more. So what if you have minus 25? Okay, minus 25, it's got to be the same thing. Okay, it's got to be the same thing. Okay, there's a little problem over here. We'll see that. We got to express minus 25. So the first thing we have is the sign bit. So sign bit, this one's got to be 1, and the value is got to be this. So the value is the same. There's no difference, right? Okay, but there's a slight problem with this. The problem is that, let's say I have a number like this, right? 0, 0, 0, 0. And I can also have a number like this, 1. Okay, take a look at this closely, right? So the first number over here, this one represents MSB is 0, right? So it's a positive number, and then the value is 0. Okay, this is positive 0. Okay, but this one, take a look. You have a sign bit over here. Okay, this one shows negative, so I have a negative, and then I see the value over here. The value over here says it's 0. So now you have a positive 0 and a negative 0 in this number format, which does not make sense. Okay, does not make sense. That 0, there's only one value of 0. There's no positive 0. There's no negative 0. So that is why there's a problem with this format, sign magnitude format, and it's not widely being used right now. Okay, and that is how people come up with another format, and that's called the ones complement format. So this is how the ones complement format works. Okay, take note of the name. It's called ones complement format. Simple, but it's still not popular. So it's got some problem as well. Okay, so for positive number, how do we write it? It's the same as the sign magnitude form. No difference for positive number. Okay, so for negative number, it is one step. We got to do one extra step over there, and this is how the extra step goes. You got to invert all the magnitude bits. Okay, let's take a look at an example. So for positive 25, put it in 8-bit ones complement format. Previously, we did 8-bit and we did a sign magnitude format. Okay, now this time it's changing. It's ones complement format. So how we do it? Same thing. 8 boxes. First thing you do is you see what's the sign. Okay, this is a positive number, so the sign bit must be 0. The rest is the same. Okay, positive 25 is this value. No difference with the sign magnitude format for positive number. Now, what about negative number? If you have a negative number like this, what you need to do is first, okay, as usual, sign bit. Sign bit is 1. That denotes this number is a negative number because we have negative 25 here. Now, what is going to be the rest? So over here, what we need to do for negative number is we need to invert the bit. So invert means you reverse. So if it's 1, you need to invert it, it becomes 0. If it's 0, you invert it, it becomes 1. So what we need to do is invert. So 1, you invert, positive 25, right? It's 1. You invert it, it becomes a 0. So 0, you invert it, it becomes 1. And so on, so forth. That is how we get negative 25. Now this time is in ones complement format. Okay, clear? This is how we write it. Right. Okay, so that's how we write ones complements format number. Now, let's move on. This ones complement format also has got a problem. I'm going to show this problem, I think, at the end of this slide. But before that, this ones complement format, because of this problem, is not widely being used, and people came out with another format, and this is the twos complement format. Okay, so twos complement format is still very simple, and it is very popular. In fact, this is the number system that we are using right now in our computer, twos complement format. Okay, so the thing is, it's the same. For positive number, it's the same as how we write sign magnitude. It's the same as how we write the ones complement format. Okay, so same representation. So let's take a look at that. And for negative number, so what we need to do is 2 steps. Step number 1, invert. step number 2, you got to add 1. Okay, so let's take a look at this example. So the first example here. So represent positive 25 in 8 bits, 2's complements. Okay, now we do the same thing. Okay, 8 boxes, 8 bits, sign bit is 0. Okay, because it's a positive 25 number over here, and the value is this. Same, it's just the same as 1's complement and the sign magnitude. Okay, no difference. The difference comes when we have a negative number. So for example, we have over here, we have to represent or negative 25 in 8 bits, 1's complement format. Okay, let's take a look at how we do that. 1's complement format is easy. All we got to do is invert that. Okay, so that was what we did the last example. Okay, 1's complement format. But now we want 2's complement format. So what do we do to convert from 1's complement to 2's complement format? It's easy. All you got to do is add 1 to that. Okay, so minus 25. So in 1's complement format is this inversion, right? And then you got to add 1 to that. Okay, so you got to add 1 to that, which means you do this addition. Okay, so you can imagine like you got 1 over here, and then you just do this addition. Okay, so what you have over here is sign bit remains as sign bit, and the rest over here, because you have 0 plus 1, and then it becomes 1, and the rest they are the same because you're not adding anything else in other number. Okay, this, my friends, is how we write 2's complements format. Okay, so far is everything okay? So you have you want to get minus 25 in 2's complement format. The first step would be put it in 1's complement format, and then you add 1 to it, and the result would be 2's complement format. Okay, I know it's a lot to digest. I do encourage you guys to take your time to digest this number format. Okay, so we've learned about this so far in this. Okay, so in binary number, that's the beginning of our chapter. We learned about binary number, and then today we learned that, oh, actually binary number, you have 2 types. You have signed and unsigned number. Okay, if it's unsigned number, you don't have a sign bit. Mean to say everything in the number, it's the value. But today we learned that we have a signed number. Okay, we have a signed number, and we have like 3 forms of signed number, and we learn how to write them. Sign magnitude, 1's complement, and 2's complement. Okay, so far so good. Any question?
No questions, sir.
Okay, let me take a look at my slides for a while to see.
All okay, sir.
Okay, right? Okay. Okay, one moment. I'm trying to estimate how much is left and whether or not I'm able to make it further. Okay, you know what? I think this is all I am going to cover today. So as usual, this already passed 1 hour, as I promised. My classes are not going to be very long because I think it's very one-sided for me to talk and then for you to receive. So in the second half of the class, what I want you to do is to take action, and that is to take out a pen, take out a paper, and do the examples in this slide. Okay, do all the examples. Like right now, you have like 1 hour. I think take 15 minutes, take 30 minutes to do out the example. And as promised also today, I am going to release another quiz that's based on the video and that's based on what we have learned today in the class. And I really do hope you guys can just finish this quiz by the end of the class. You got, right? So we have 1 more hour, right? So just take your time and settle it right now, and you don't have to really think about it anymore. Okay, so today, take home message, we've learned about sign numbers, and we've learned also about what was that just now? The arithmetic. Yeah, we've learned about arithmetic, and we've learned about the sign numbers. So in the next class, we are going to combine. Yeah, we're going to combine these 2 elements. We're going to take numbers that is in 2's complements format, and we are going to take arithmetic, and then we are going to do this operation on them. So I really do hope you guys take this, understand this concept before the next class, because otherwise the next class will be, you'll be lost in the next class. All right, so if there is no any question, I would like to, okay, show this attendance again. If you came in late, do scan your attendance, and I'll release the quiz immediately after the class. And if you don't have any question, thank you very much. I will see you guys again soon. Bye-bye. If you have any questions, feel free to stay back. I'm ready to answer your question.
Thank you, sir.
All right.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Right.
Thank
You're
you,
welcome.
sir.
You're welcome. See you guys. Take care.
So, sir, that means after this we have the quiz to do, right? And the questions that you asked us to try about the multiplication and division, is it?
Yeah, you have the quiz. The quiz will be in Teams, and it's just like previous quizzes. You got to answer them. So the rest, the examples, I really do hope that you guys will be doing them yourself. Okay? I won't be checking them. I won't be asking whether or not you did this, whether or not you did that, because you guys are an adult, right? I don't want to treat you guys like secondary school kids. Okay? So you guys know how to, how to excel in the class. I'm telling you guys how to do well in the class. So whether or not you want to follow, it's still up to you. It's your personal freedom. It's your free will. Okay? But highly recommend you do it. If you have any problem, I'm ready to help you guys out. Okay?
Sure, sir. Thank you.
Okay.
Thank you, sir.
All right. You're welcome.
Can I ask a question?
Yes. Go ahead.
About the 2s complement format. What if it is -3 in the binary for 2s complement format?
-3. What do you mean -3? The number is -3 instead of negative.
-3 in decimal, and we want to change it into binary in the 2s complement format.
Okay. So first thing, what you want to do is you get this -3, right? Okay, let me just scribble here. -3. Okay. First thing, what you want to do is to see you got 3. You want to know how many bits of the number.
Yes.
Okay.
It's gonna be 3 bits. 111.
Okay. Okay. So there's got to be a requirement in the question saying how many bits are the numbers. Okay. Like for example, over here, right? It is mentioned over here. It's 8 bits number. Okay. So you got to know this one. Is it in 8 bits format or is it in 5 bits format? It can be. It's different answer. Okay. So if it's -3, you know that okay. At the end of the day, it's got to be 8 digits. Okay. So first thing you do is, as usual, you get the sign bit first. Sign bit's got to be 1. Then okay, and then the rest is as usual.
Yeah.
You get the value.
Sorry, sir, but the reason I asking is I'm thinking about what if the format is it's gonna be 1 for all of the 8 bit. Okay, 1 for all of the 8 bits, and then we're gonna add 1, right? To change it into the sec2s complement format. So what will it become? I don't know how to.
I don't quite understand what you're trying to. You mean like everything is 1? Is that what you mean?
Everything is 1. If, for example, everything is 1 in the first complement format, and then we want to change it into the second complement format.
Okay. Yeah, that is actually a valid question, and we will cover that in our next lecture.
Okay.
Yeah,
Sorry,
because you see for this 8-bit number, okay, there is a minimum value and there is a maximum value that it can represent. Okay, so same thing in decimal, right? If I tell you, okay, if I have 3 digits in decimal, what's the minimum number that you can write with that 3-digit decimal? The minimum number you can write is 000, right? That's decimal. What's the maximum number that you can write with the 3-digit decimal number?
111.
I mean decimal number.
Decimal number.
Decimal. This is the maximum that you can go with the decimal number,
Oh, okay.
right? So this is a minimum number. Minimum means the smallest number that you can write with a 3-digit decimal number. This is the largest number that you can write with a 3-digit decimal number. Now, in the same thing, 8-bit binary sign magnitude, 8-bit binary sign ones or twos complement, there is a minimum number that you can write and there is a maximum number that you can write. So that is called the range of the number. Okay. So if you're curious, you can, the slides are already in the Teams. You can just go through the slides for the next class and you know what I'm talking about. What's the minimum and maximum number that this format can support?
Okay, sir. Sorry for.
No,
Okay,
don't be
thank you,
sorry
sir.
don't be sorry when you ask questions. That's what I'm here for. Otherwise, like you might as well watch a YouTube video, right? So do ask me questions, like even if you think it's a silly question. No, I don't think any question is silly. It's just about learning them. Okay.
Okay, thank you, sir.
All right.